Hello everyone. In today's video, we'll be learning about integration and infinite series. We are looking at how exact technique meets series approximation for engineering calculations. As we go through these slides, we want to answer a central question. Can we compute area exactly or approximate it safely? By the end of this video, we will explain and define integration and infinite series, solve examples using two distinct integration techniques, compare and connect those same examples to series, and at the end of the video, I'll be showing you a practical engineering use for these methods. So let's establish the core ideas first. Integration adds while series approximates. An integration finds an accumulated quantity such as area, work, charge, or distance. Meanwhile, an infinite series writes a function as an endless sum of simpler terms. The fundamental connection between them is that a series can be integrated term by term when it converges. As a rule of thumb for this video, we will provide the exact answer first and then series approximation second. So let's look at our first example, and which is as well as our first question. Here is our objective now is to find the integral 0 to 1 2x exponential x squared dx. Right. So first write down your question. Integral 0 to 1 2x exponential x squared dx. Then we'll be using the u substitution to solve this question. So first, we have to find the u that can cancel with the 2x after derivation. What does that mean? So you have to find, you have to look at the question and see what can cancel with this 2x, what cancels the 2x after derivation. So we have x squared here. So we'll put x squared as our u. After deriving x squared, we get 2x. As you can see, we get the same value, which is 2x and also 2x here. Then we move the du over, and we'll be left with dx equals to du over 2x. Why is that important? We need to find dx so we can plug it in into this formula or this equation. And after plugging into this equation, we'll be left with this. So integral 0 to 1 2x exponential x squared, and then we'll be left with du over 2x. After getting that, we can cancel them out, and we will be left with exponential x squared. Then we substitute 0 and 1 into x, and we'll be left with exponential 1 square minus exponential 0 square, and the final answer is this. And in order to find the exponential 1 square, you can just plug it into the calculator and you'll get the answer. Right now we're going to look at the same integral using an infinite series. So based on the formula booklet, we know that exponential x squared is equals to this. Then our question there is 2x and exponential x squared. So we just times 2x into exponential x squared formula. And then limit 1, so it is integral 0 1, so we take 1 sub into x. So after subbing in and simplifying, you'll get this, and then plug into your calculator, you get your answer here, which is almost similar to the u substitution method. And so for our second technique is integration by parts. What is integration by parts? Integration by parts allows us to split the products of two functions. And here are the steps that follows. First, you have to choose u, which is pick the part that becomes simpler after differentiating. Next is choose dv, pick the part that is easy to integrate. Then third is apply the formula. Use this formula over here. And finally is reevaluate. So you use bounds carefully for a definite integral. Alright, so looking at our question over here, next question, moving on, we'll be doing integration by parts on this question over here. So we have integral 0 pi over 2 x cos dx. So first step is write down the question down, and then next thing we have to do is find u. So how do we determine u? We determine u by using this formula over here, this rule over here. So what this rule means is that the first one that comes up, ascending order, has priority to become u. So from left to right has priority to become u. For example, we have logarithm. Let's say we have logarithm and inverse in the same question, the same equation. Our u will automatically be the logarithm. Our logarithm will automatically be u. And in the another example is, let's say we have algebraic and trigo in the same equation. Our u will be the algebraic and not the trigo. Well, for this question over here, we have algebraic and trigo. So our u will automatically be x, which is the algebraic. Then next we will differentiate x, which is du over dx. We'll get 1. So we'll move dx over. So we'll get du equals to dx. And next we'll find is dv equals to cos x. Then we integral. V equals to integral cos x. We'll get sin x based on here formula booklet. Right. Then we just plug this into the formula, du, dv, and v into the formula, and we'll get this. And then we'll just sub the 0 into x and pi over 2 into x. We'll be left with this. And then after solving, like plugging into the calculator, we'll get this and the final answer. Alright, next we'll look at the series comparison for by parts example. So based on the formula booklet, we get that cos x is equals to this, but we are trying to find the integral of pi over 2 x cos x dx. So we just basically just times x into cos x, which is times x into the equation, the formula, and then we are left with this. Then just integrate, which is pi over 2 into all the x value, all the x, and then we get this. After we get this, and after simplifying and typing into the calculator, we get this as the final answer. So for series, we normally only do a few terms because yes, doing many terms, your answer will be more accurate, but it will get to a point where your answer, you'll get to a point that it doesn't matter because after rounding up, you'll still get the same thing. So yeah, you can see we get 0.5708, and as the last answer, we also get almost the same thing. Right. In the real world, this math serves a practical use in processing signals, calculating heat, and managing energy. The standard engineering workflow follows these 4 steps. Model a changing quantity, approximate difficult functions, integrate for a total effect, check accuracy by adding terms. Why does this matter? Integration turns rates into total quantities such as work, charge, heat, or distance. Meanwhile, an infinite series lets engineer approximate complicated functions with polynomials, while U substitution and by parts give exact answers when the structure fits. The ultimate takeaway is to use exact techniques when possible and series when approximation is practical. That concludes my video. I hope you enjoyed, and I hope that I was able to help you guys to understand about this topic. If you have any questions, you can leave them in the comment section below. Thank you for watching.